in this part, which is part 3 of creating the stack proportional circular area chart, we're going to work on pushing this down. So far you already had some understanding of it, but let's start to explore this a bit more deeper. So what we could do basically is something like this. We're going to say here that we have here, for example, this data set here. So that's data set number 1. And we're going to say here the data set number 1 has the Y position. And the Y position, we want to push this down how many pixels? Well, basically, we will need here some information about the bottom. How much is the bottom? And then we have to go up as well. So we can say here, for example, if I do here bottom, it goes down here. But as you can see here, what we do know is whatever is the bottom, then we have here the outer radius, how many pixels that is, and we want to push that up. So basically bottom minus the following. I'm going to grab here the outer radius, and specifically the outer radius of chart dataset number 1. Let's do it like that. And I'll say here, this will be like that. And as we do this, it pushes up exactly. So what happens basically is, once we have to have the outer radius is the starting point from this point to the basically this point here, or that's the half of the slice, which is basically the radius of a circle. So we can use this to our advantage in this case. So what we can do as well is if we want the other one as well, we're going to grab that, do the same logic, but then we say number 2, save, and there we are. So now it starts to look quite nice. Of course, this here is quite excessive, a lot of information here. Let's make this a functionality. So what we can do here is we're going to say here data sets, and this is the reason why we have here the data. And we say here then the for each loop, so that for every data point we have, we will start to expand it or figuring out how to push that down. So what I'm going to say here, for each, we say here every data, I guess here, the data set as the shorthand, and then we say index, function error expression, and then in here we can just grab this, put that in there, and then we can say here for every index. Of course, if we do this, and let's comment out this one here, save, refresh. Oh, alright, it works very nice. Apparently that is more than enough. I thought maybe we need to consider to escape the upper one, but no need, it understands this. What you do see here, and this is what I don't like, is this line here. I'm going to remove the border lines here. You can say here border width, but I'm just going to remove all of them, and I'm going to use a universal application. Basically, apply it on every one of these borders or data sets by saying it in here, very similar to what we did with the cutout percentage. We're going to say here border, I guess the border width will be equal to 0 pixels. Save that. Refresh. Now we have this nice looking item here. What we could do here is, of course, to give it a hover background color. So what I will do is just copy this, put it in here, and then we'll say here hover background color. Then what I will do is I will copy this and apply that on every item here, and then after I will adjust the coloring. I want the background color to be a solid red color or whatever the color we assign here on the border. But this border color here I want to maintain because I will draw a custom border myself. So if I save this, refresh, now if I hover over it, you can see what is happening. Of course, this is not really the very perfect option because you can see here it is not really optimal, but there is no other way for me right now to solve this, so I will not go deeper in depth. But what we do have is still our circular effect on the border. As you can see here, we're missing that, and that will be in the next video.